okay? So what I want you to do is on your whiteboards, I want you to write at the top the trinomial x squared minus 8x plus 16 equals 0. Okay? We're going to build this with our tiles, okay? So you can actually just grab these pieces as you need them, okay? So what you're going to do is just on your whiteboard, take one piece that's going to represent our x squared. Okay? So one piece that represents our x squared. Now, we need minus 8x. Okay, so these are our x pieces. The negative x is the red side. So we need how many of those?
8. Does it matter?
It doesn't matter yet. It will eventually matter, Alexa. Good question. So right now, just pull out 8 pieces. Good. Okay.
Oh, this one's like.
Oh yeah, get rid of that one. It might just be from a different set. There's a couple mixed sets here.
That's fine. Can they save like different?
That's fine for now.
Okay.
Yep, that's fine. Okay. And then we need 16. This is a little bit more tedious. We need 16 of these little pieces. And if I need to grab a few more, I can. And they're going to be on the yellow side. Very good, because that's going to be a positive 16. Okay, so go ahead and grab those. I've got more pieces coming just in case we need them.
On the yellow side, you said?
Yeah, so on the red side for these tiles always represent the negative. So if we had -5 or something like that, for example, we would need the red side up. Because it's a 16, it's kind of a high number. It's a little bit of a tedious thing to count them out, but that's okay. All right, now I've got my. Good. All right. Now our goal is to arrange these pieces. You get it, Lucas? Okay.
Yeah.
Now our goal is to arrange these pieces to make a square. Keep in mind that a square has the same length as it does width, right?
Right.
So Alexa asked earlier, does it matter if we have them horizontally or vertically? Well, in this case, we have 8 of them, right?
Yeah.
So we're going to actually put 4 along the side horizontally and 4 along the bottom vertically. I said it backwards, but you get what I'm saying. So 4 along the bottom and 4 along the side. Now I know we have this gap here, okay? But if we're looking at just our length and just our width, are the length and the width the same right now? Here and here. So along the top and along the left, they're the same, right? Do we see that so far?
Yeah.
Okay. Now we're gonna fill in our units, okay? So the units are gonna just go right in where our gap is. So Emma, the only suggestion I would have, and Lucas, same thing, actually all 3 of you, okay, so it's fine. I would rotate your whiteboard so that your length and your width are gonna be exactly the same. So right now, you have yours. Hang on 1 second, let's see what we got going on here. You're fine.
Oh, I got you.
This little square is like miniature.
Oh, I know.
You're fine. There we go. All right. So then we just need it to be 4. Does that make sense? Okay. So right now, what is your? Okay, I see. You got your length and your width here. Good. Where's your length and your width, Emma? is if you do your length here and your width here, are they gonna be the same?
No. Wait. No.
This would
Because
be,
this is longer.
right, well, no, it's not necessarily about how long it is, but how many units is this?
Oh, this is 1 and this is 4.
This is an x, right, a
Yeah.
negative x, and this is 4, right?
Yeah.
What about this?
And then this is x squared and then negative x.
Right, so those aren't gonna be the same length and
No.
width, right? So what I'm suggesting is, you see how Lucas said that his length and his width are here?
Yeah.
Because this is the exact same as this.
Oh, yes, okay, I see.
Make
I see.
sense?
Yes.
Okay, so where's your length and width gonna be, Alexa?
My length.
So you're here and here, because
Okay.
that's gonna be exactly the same. So I would rotate it just so that you can kind of see
But
That?
makes more
like
sense.
that. Does that make sense?
Like a flag.
Because, yeah, kind of. So then this is the same as this.
Yeah.
Because a square has to have the same length and width.
Yeah.
Make
That
sense?
makes more sense.
Okay.
Mhm.
So, what is our length? Or our side length? What is our side length?
4. Well,
There's gonna be some
Oh.
4 somewhere. For what?
negative 4x.
Negative 4x. I see that. Do you guys see that here?
Mhm.
Right here and right here. That's negative 4x. Okay? Okay. What about this part, the blue side?
The blue side. Well, that's x squared.
The whole area is x squared.
Mhm.
What is its length?
Oh, would be x.
It would be x, right? So x would be the length.
Yeah.
So if we take this first side, which is one of the factors of this trinomial,
Mhm.
it is x minus 4. Is it minus 4x? Or is it just minus 4?
It would just be minus 4.
Yeah.
Okay, why? How do we find the area of
Length times width.
length times width? Okay,
Mhm.
so take one of these little long pieces out. Okay, take one of the long pieces out. What is its length and what is its width? We know the area is going to be equal to x, right? What is its length?
X.
It's x. What's its width?
1.
1, right?
Mhm.
So if I put two of these together, okay, it would equal 2x, right?
Mhm.
But what's its length and what's its width as they are together?
X.
The
and
length
then
would be
2.
x
X
and
and
2.
2, right? Does that make sense?
Yeah.
So if I push these back over, it's not actually minus 4x here, it's really just minus 4. You with me so far?
Yeah.
Okay, so the first factor is x minus 4. The next factor, the width, as you know, if you will, is also x minus 4. And we could write that as just x minus 4 squared. Okay, that's a perfect square trinomial. Okay, does that make sense?
Yes.
Okay. Now, in a perfect world, all of our trinomials would be able to factor and be perfect
Right.
squares, right?
Yeah.
But that doesn't happen, okay? So this strategy can still be used when we're converting to vertex form, okay? So I want you to clear your boards.
Of everything?
Yeah, clear them of everything. Yeah. You'll need those tiles again in a minute. Okay, the new equation that we're gonna try to work out together is gonna be x squared plus 6x plus 8 equals 0. Okay, now, can you tell by looking at this right away whether it's a perfect square trinomial or not? Is x squared a square?
Yeah.
Right, it's x times x, right?
Yeah.
What about 6?
No.
It's not, right? And what about 8?
Mm-mm.
Right. In the last problem where we had 8 and 16, we know that 4 plus 4 is 8 and 4 times 4 is 16. So we can look at that one and see that that's going to be a perfect square.
Yeah.
Okay. But in this case, 6 and 8, it's not going to work out. Okay. But we can still use this method. Okay. So before you get started this time, I want you to make just a frame here. We're gonna call it a frame. This is where you're gonna build your model, okay? Okay, so length and width. So Alexa, just do, yep, you're good. Yep, just like that. Okay? All right, so we're gonna build inside of this area here, and then we're gonna know where our factors are on our left and our right, okay? All right, so let's start with our x squared. So x squared, we can put that right in the corner, okay? Now, what are we gonna do next? 6 of those, good. Six of those, and we need them on which colored side?
The green side.
The green side. Okay, and I see you already putting them right where they need to be. How many are we gonna have on the side versus on the bottom?
3 on each.
Yeah, 3 on each, you got it. These different size things.
I have a question.
Yep, sure.
What would we do if it was a like 7 where it's not perfect? Like if
A
it was
7
x
what?
squared plus 7x. You know what I mean?
You mean not an even on each
Yeah.
side? So I'm gonna show you.
Oh,
I'll show you. Yep, so we'll end up, you can build that too, okay?
Okay.
So let's get this. That's a great question though, Emma. Okay, so let's get this built. You guys are ahead of me. All right, and then what's the next step that we need?
Oh, we have 8 little ones.
8 of the little ones. You got it. 8 of the little ones. Is it gonna be positive or is it gonna be negative?
Positive.
Positive, yeah. I mean, you have different size pieces,
Yeah.
so let's just do this one.
Okay.
That
and then
way.
condense it.
Yeah, you got it. Perfect.
It's supposed to be 8, not 9.
It's supposed to be 8, not 9, Lucas. Why would you think that maybe it's supposed to be 9?
Because if there was a 9th, you could make it perfect.
Yeah, if there was a 9 there, we could make it perfect, but it's not. That's a problem, right?
Yeah.
And that's why this is one of those non-perfect square trinomials, right? So we've recognized that we've got a problem here,
Yeah.
okay? However, let's just make a note of this. I'm gonna make an arrow here and be like, we're gonna make a sad face. Uh-oh, it's not there, okay? We still have a length and a width, okay? It's not perfect, so there's gonna be something that we're gonna have to do to fix it to make it perfect, okay? But as of right now, pretend for a second that it is, okay? What is our length and our width going to be? I like your thumbs down. What's our length and width gonna be? So what is this blue section?
It's x.
That's gonna be x on both sides, right?
Yep.
Okay, and what about the green pieces?
It'd be 3.
It is gonna be 3, okay, good. Is it gonna be plus 3 or minus 3?
It'd be plus 3.
Good, it's gonna be plus 3. Does that make sense?
Yes.
Okay, so as of right now, I could write this original trinomial, x squared plus 6x plus 8, I could write that as what?
X plus 3
Mm-hmm.
and x plus 3 in another set of parentheses.
Mm-hmm. X plus 3 times x plus 3.
And then would you subtract 1?
Ooh.